The final section in Chapter 7, we're going to talk about natural logs and how to solve those. This, if anything, will probably be a little bit easier than what we did in 7.5. So, pretty chill video, not a ton to go over here. Again, just to reiterate what E is, E officially is called Euler's constant. I don't know if we went over that before. And it's a fundamental mathematical constant like pi, so it's like one of those commonly used kind of numbers that it's irrational, so we have our own symbol for it. It's irrational and a forever repeating decimal, and y equals e to the x would have an inverse. That inverse would be natural log or ln. And another way you could look at that is like log base e is natural log. Okay, so y equals log base e to the x. I could rewrite as just saying y equals the natural log of x. So I would definitely write that down, put that in your notes. That'll kind of be the key as we're working within this unit or this section. So let's just start by simplifying natural logarithms. So we've done this already with logs before. They follow the same set of rules. Let's just look at a couple with natural logs. I want to write 2 natural log 15 minus natural log 75 as one single natural logarithm. So first, when I have that coefficient 2, remember that can go up as an exponent. So now I have natural log of 15 squared minus natural log of 75. But when they're subtracted, remember, I could write them as divided over each other. And that number is just 225 over 75, which is 3. So that expression simplified would just be the natural log of 3. Now let's move on to solving natural logarithms. I want to solve for x here. Here I have ln, or natural log of x minus 3 squared, equals 4. So what I'm going to want to do first is get that natural log by itself. Not that. First I want to get rid of the natural log. The natural log is by itself. So what I'm going to do from here, to get rid of a natural log or to undo a natural log, is I'm going to take everything to the e power. And what you'll notice here, e to the natural log kind of cancels each other out. So now I could write this as just x minus 3 squared equals e to the 4. Now I can solve, square root it. Now I have x minus 3 equals plus or minus e squared. Add the 3 over, and now I have x equals 3 plus or minus e squared. If I put that in my calculator, my answers here would be 10.39 and negative 4.39, like rounded to the nearest hundredth. And then also, I think just, especially when we're working with weird and newer numbers, it's a good idea to kind of just be in the habit of double checking, especially for a problem like solving for x. So if I plugged like negative 4.9 in for this equation, the natural log of negative 4.9 minus 3 squared is going to be around 4. Again, remember we're rounding, so it's not going to be exact. Same thing with 10.39. So again, just as we're working with maybe numbers that we're not as familiar with, I think that's just always a nice thing to come back to plug it back in, see that those numbers that you found works out. Now let's work the other way for solving for an exponential equation. Here I want to solve 4e to the 2x power plus 2 equals 16. First I'm going to subtract 2 on both sides. Then I'm going to divide 4 on both sides. Now I have that e to the x all by itself. So now I can finally deal with that exponent. Now remember, natural log is log base e. So I could kind of write this as natural log of e, because that natural log is going to get rid of that e. So when I do natural log of e, this cancels, and I'm left with 2x equals the natural log of 3.5. Now, natural log of 3.5, I could write that into my calculator, so now I can kind of just solve like a regular algebra problem. I divide both sides by 2, I'm left with x equals 0.6264. And again, just to get in the habit of double checking, I'm going to plug that in, and I get 16. So I'm good to go.